To further continue, in the previous lessons, we spoke about model in loop, software in loop, and hardware in loop. So let's see in a slightly more elaborate manner what these in loop testings are. In the context of vehicle diagnostics and onboard diagnostics, model in loop, software in loop, and hardware in loop are critical simulation and testing environments used across the development life cycle of automotive ECUs and diagnostic systems. And these methods allow developers and test engineers to validate diagnostic logic, UDS services, DTC behavior, and ECU responses without needing a physical vehicle in physical vehicle in early stages. Understand this very carefully. It does not require any physical vehicle. The actual vehicle is not required because testing on actual physical vehicle is a very tedious task and expensive task. So most of the simulation testing must happen in a virtual environment, and these MIL, SIL, and HIL, they aid in that virtual developing the virtual environment and testing without much effort and without much expenditure. Now when it comes to simulation level description, MIL, SIL, HIL. Now, coming to testing diagnostic models using simulation tools like MATLAB, Simulink, and testing compiled diagnostic software in virtual environment, testing diagnostics on real ECU hardware connected to simulated vehicle systems. All right, so MIL, SIL, these are the brief description. I request all of you to go through this in a more elaborate manner. And let me point out that in YouTube there are beautiful explanations about MIL, SIL, and HIL also, about clearly explaining through the actual demonstration about MIL, SIL, and HIL. Now, when it comes to why you use MIL, SIL, HIL for diagnostics, it detects the bugs early. Okay, so it detects the bug early in DTC logic, parameter scaling, and UDS implementation. So understand this: earlier you catch the bug, the more easy and more less expensive it is. And next is it simulate the faults. Example: sensor disconnection to validate diagnostic responses. So verifying communication protocols, can UDS can be under various loads, and avoid physical damage by testing high risk scenarios virtually, ensure compliance with safety, security, and emission regulations. Okay, understand this very carefully. It ensures the safe compliance with safety, security, and emission regulations. So when it comes to model in loop, what is model in loop? Model in loop involves simulating diagnostic algorithms. You simulate the diagnostic algorithms using behavior models, typically in MATLAB or Simulink, before any code is generated. All right, and next comes the diagnostic use cases, where you validate DTC trigger conditions modeled from system equations, simulate sensor models and actuator models, and test diagnostic state machines for correct transitions. Now, when it comes to verifying thresholds, timing conditions, and enable disable conditions, tools MATLAB, Simulink, Stateflow, Model Advisor. These are the various tools that are that are used for simulating the diagnostic algorithms. And what are the major benefits? One is quick iteration. Next is visual debugging of the diagnostic flow, and ideal for early phase fault verification. Now, this is the most important purpose or reason why model in loop is a must. Okay, so you can detect the faults at a very early phase. Now, when it comes to detect software in loop, what is software in loop? Software in loop detects the tests the compiled diagnostic code or AUTOSAR components in PC-based virtual environment. Understand this very carefully. In PC-based virtual environment, and no hardware is involved. Only the PC-based virtual environment is required. Now, when it comes to diagnostic use cases, the test actual UDS service handlers, example 0 by 19 for DTC readout, validate diagnostic software for memory handling, error logging, and response formatting. Now, when it comes to run automated test scripts to simulate fault codes, DIDs, live data. Okay, now when it comes to the tools, Vector Virtual Target, ETAS Isolar Eve, DSpace VOS, Simulink Coder, these are the various tools which are used in software in loop. Now when it comes to benefits, software behaves like a real ECU, allows code average and MISRA rule checks, and ideal for unit and integration testing of diagnostics. Okay, so this is the major advantage or major application of software in loop testing. Now, when it comes to hardware in loop, what is hardware in loop testing? Hardware loop testing involves diagnostic software on the actual ECU. This is extremely important, on the actual ECU while connecting it to real-time simulation of the vehicle system. Now, let me point out, you can in YouTube there are some beautiful videos by company ETAS or companies like DSpace which have given beautiful explanation along with the demo in their videos. All right. Now coming to diagnostic use cases, simulate faults. Example, open circuit sensor failure to test a DTC generation. Validate OBD readiness monitors freeze frame and live data streaming, and verify security access mechanisms and session timeouts. All right. Now, ensuring UDS response time under real bus load condition, example CAN or diagnostics over internet protocol, perform regression testing with various fault injection scenarios. And again, the tools used are DSpace HIL system, ETAS LabCar, National Instruments PXA based health, Vector VTU system, Cano CAPL scripts, and benefits like closest to real world testing before in vehicle validation, essential for compliance and safety verification, and required for ASPICE ISO 26262 OBD certification. All right. So these are the major benefits of hardware in loop. Okay. So I request all of you to pause the video and go through this particular table. It clearly explains, elucidates the various features and what are the various what activities that are accomplished in MIL, SIL, and HIL. Okay, so I will not go through these things. I will just breeze through them. For example, typical tools I have mentioned here. Test automation is mentioned here. I have also clearly explained you whether what it is ideal for. For example, MIL is ideal for concept testing. SIL is ideal for functional software, and HIL is ideal for software level validation. So I request all of you to pause the video and thoroughly read this table. You will clearly understand what MIL, SIL, and HIL is referring to. Now, when it comes to integration in V model and ASPICE, system design, software design, implementation, unit integration, system acceptance test. Now here in the V model and ASPICE context, okay, so which of the various steps are accomplished by MIL, which of the various steps are accomplished by SIL, and which of the various steps are accomplished by HIL? It is clearly mentioned in this tabular column. All right, so let me reiterate, to get a thorough understanding of V model, you have to do a lot of homework. All right, so once you get a clear command on the V model, then you will not then you will clearly understand where exactly MIL is playing an active role, SIL is playing an active role, and HIL is playing an active role. All right, now when it comes to DTC validation in MIL, SIL, and HIL, MIL, SIL, and HIL, it for example, you are taking the example of P0102 mass airflow. In MIL, you simulate the mass airflow sensor model, and in SIL, you trigger the fault in mass airflow diagnostic software component, and in HIL, you inject the low voltage to MAF pin on real ECU. When it comes to validate logic thresholds, check UDS response with service, real DTC on scan tool, and verify OBD format and plot behavior on Simulink. Now, unit test result during diagnostic steps. Okay. Now, when it comes to validate, frame and mill light behavior, these are the this is what happens in the HIL. Okay. So in this particular diagnostic example, what is happening in the mill, what is happening in the SIL, what is happening in the HIL is clearly explained in this tabular column. Now coming to the, I want all of you to understand this summary. Mill, it simulates the diagnostic logic at model level. SIL, it validates the diagnostic software. HIL, it tests the diagnostics on the physical ECU, and all it helps the reducement cost, catch issues early, and ensure compliance. All right. So here's a visual representation coming your way that outlines the security access, diagnostic service transitions across the mill, SIL, and HIL validation stages. It will help break down the simulation to hardware journey, and I request all of you to understand this drawing very carefully. Model in loop, just the logic, software in loop, software in the ECU, and hardware in loop, the actual ECU plus the actual vehicle or simulated vehicle. But ECU will be the actual hardware. Okay, so hope all of you got a clear cut idea about the HIL, SIL, and MIL. Thank you.